Hello everybody and welcome to the very first lesson of the Pixie Mega Drive Genesis tutorial series. As many of you know, the Mega Drive has two background layers, the background and the foreground, and in this lesson I'm going to show you how to put them both on the screen. For those of you who missed the intro video, please go and watch that, it tells you how to set everything up, but for everyone else, let's get straight into it. The very first thing we're going to do is make a copy of the Pixie template and call it background. And next we're going to open up that folder in Visual Studio Code. If you look under the src folder, you'll see the main.c file, and this is where we're going to be writing the majority of our code for all of these tutorials. But before we write any code to display any backgrounds, first of all we need to load those backgrounds onto the ROM or onto the cartridge. In order to do that, we're going to create a new file called resources.res under the res file. It's in this file where we're going to tell the SGDK system what resources we want to load onto the ROM. Now if you check the video description, you'll see a download link, and from that link you can download these background images. Now what we're going to do now is to copy these background images to the res folder, and these are the images we're going to be displaying on the screen later. But just because we have copied them over, it doesn't mean that they're going to be on the ROM yet. So in order to put them on the ROM, we're going to have to write some code. Now each line of this file is going to represent a different resource. Over the course of these tutorials, we're going to be putting lots of resources onto the ROMs, for example, sound effects and sprites and music, but in this lesson we're going to put an image in. So the first thing we have to do is tell SGDK that this is going to be an image file. For anybody new to computer programming, things like spaces and whether any writing is uppercase or lowercase is very important, so please just write exactly as I'm doing it here. So for example here, image needs to be written in uppercase letters. The next thing we're going to have to write after one single space is the name of the resource. So this is going to be the name that we're going to refer to it throughout our program. So you can call this whatever you like. I'm just calling it BG1 here, but so long as there aren't any spaces in between the name, so long as there's one continuous piece of text and it's not too long, then it should be fine. So call it whatever you like within reason. The third piece of info after another space that I've written here is the name of the file in quotation marks. So don't forget the .png, but it's pretty straightforward. The fourth piece of info after another space says best in capital letters. Now you might be wondering what best means. This refers to the compression, and you might think, why would we choose anything other than the best compression? But we'll see, especially when we get to the sprites lesson, that that's not always the best option. And lastly, just write all for now in capital letters, ALL. There's nothing important that we need to deal with right now. I just want to draw your attention to the circle next to resources.res, and as I've clicked Ctrl S to save, you see it's turned to an X. Now before we compile anything, we want to always save, so make sure you always save when after you make changes. You can just click Ctrl S as I did there. And now I've opened the terminal. I've just typed CMD just to get it away from the PowerShell. Now I'm going to do Ctrl Shift and P, and I'm going to compile it. You can think of compiling as creating the ROM basically. So now we've created the ROM, but the problem at the moment is the main.c file. It doesn't know of the existence of this resources.res file. Now you've heard the expression all roads lead back to Rome. Well, all files must lead back to the main.c file, so we have to make sure that it knows of the existence of this resources.res file. So you can see here I'm just adding another include line of code similar to the include.genesis.h, which links in all kinds of SGDK functions, but this time we're doing the include.res so we can include that too. Okay, and since we're going to be displaying graphics today and not text, we can get rid of that text function. And now let us set up the VRAM so it can take the tiles from our graphic. Now you're going to want to start writing this exactly where I'm writing it right now, which is just under main. So we're going to write u16 ind equals tile user index and then a semicolon. And I just realized that I did a typo, the second underscore shouldn't be there, and I'm going to correct that now. And you might be wondering, what does U16 mean? What does IND mean? What the hell is tile user index? But don't think about it too much now. This is just setting up our graphic, our tiles from the graphic into VRAM, so I'll skip past this for now, it's not really essential to know. For the next step, we're going to set up the palette. In order to do so, we're going to use this SGDK function here. Now, when I talk about functions, you can think of it as almost like a tool. It does something for you. So in this case, it's going to set a palette for us. And in order to get it to do what you want, you need to give it some information. Just as if you wanted to book, say, a flight online, you'd have to tell it where you're flying from, your destination, what class, what day, what time. When you use these functions in SGDK, we're going to use one to put something on the screen later. You have to give it information too. Fortunately, as soon as we open up these brackets, we get this little guide about what information we need to put into the function. For this particular function, we need to give it 3 pieces of information, the first of which is to tell it which palette number to assign the palette to. Anyone who's been watching my videos over the past few months knows that of the 64 on-screen colours displayed by the Mega Drive, they're split into 4 different palettes, PAL 0, 1, 2 and 3. In this example, we're going to tell the function to set the palette for PAL 0, and we're going to set it with the colour information from our first background graphic. So remember, we called it BG1. So you just type in bg1.palette -arrow and then data. And again, don't worry too much about what every single letter means, just know that we need to tell SGDK where to find the palette information from, and in this case it's stored within the image we're using. Okay, and then the third and final piece of information is the transfer method. Now you may recognize some of the letters here, especially DMA for direct memory access. So we can choose DMA or tell the CPU to get the information for us, but it doesn't really matter at this stage, so choose whichever one you like. I'll just choose DMA out of habit, but it's not really important. Okay, now that we've told SGDK which colors we want to use for PAL 0, now let's put the image onto the screen. And in order to do that, we're going to use another function. This function is called VDP_DrawImageEx. And again, when we open up the brackets, it will tell us what information we need to give it before it can do its job. The first piece of information this function needs is to know which background plane to display our image on. I'm sure most of the people watching this already know, but the Mega Drive has 2 background planes. SGDK refers to these as BG_B and BG_A. B is the background and A can be thought of as the foreground, so we're going to use the background B. The second piece of information our function requires is to know which image to display. So we called our image BG1 before, so that's what we're going to write here, albeit with a slight difference. We need to write the ampersand or the and symbol at the very front. Don't ask me now why we need to do that, it will take a long time to explain, but just make sure you do write it. For this third one, we're not going to put in just one piece of information, we're actually going to use a macro called tile attrib full, and we're going to use that to enter several pieces of information as you're about to see here. As soon as we open the brackets, you can see that it asks us for 5 pieces of information. The first one, highlighted in blue, is PAL, so it wants to know which palette to use. Now, just before we did this, we set up the PAL 0 palette with the color data from the image, so obviously we're going to use PAL 0 here. And next up, it's asking for something called prio. Now you might guess that this means priority, and you'll be correct. So anyone who's watched my shadow and highlight videos or any of the Maria and the forest on the horse video will know that priority is very important. So normally the background appears at the very back and in the foreground in front, and finally the sprites in front of that. That's the normal state of things, but we can manipulate this using this priority lever. We can set it as true or false. For now we're going to set this to false because we're not going to use it right now, but we're going to use that in the future. Next up, it says flip V. Now we're going to put this as false too. You've probably guessed that means flip vertically. So I'll take the image, or rather each time flip it vertically, and then the flip H will flip it horizontally. And finally we have the index, which we just do as IND, which is exactly what we did earlier. If you remember, we set up the VRAM, the indexing of the VRAM. So that's why we set it up to begin with, and we set it up there. And now finally we're out of the tile attrib full, and we're back within the normal VDP draw image. So we're finally getting on to the next part of that. The next 2 pieces of information it's asking for is U16X and U16Y. Now from X and Y you're probably guessing their coordinates, and that is correct, they are coordinates, so it wants to know where on the screen to put the image. For now we're going to do 0 and 0, so it starts from the very top left of the screen, and that suits our purposes now, but we'll explore this a little bit later. For this next one, this load PAL, just choose force always. It's about loading a palette, but we already did that anyway, so just choose force. And for this DMA, whether to use DMA or not, choose true. And then finally close the brackets and then add a semicolon, and then we are done. Now if you're confident that you've written everything correctly, it's time to save and then compile. So to compile, I hit Ctrl Shift and P, and then choose the compile and run project, and then it will compile and it will open up the Gens emulator for us. And I'm sure that this is a scene very familiar to all Mega Drive fans. It's everyone's favourite cafe and diner, the Pine Pot. And if that's worked, then congratulations, give yourself a massive pat on the back. You have just programmed your first Mega Drive background. And for those of you who had a little bit of an error, don't worry, just read through the code once more, make sure all the semicolons are in the right place and everything, and there's spaces and commas, and I'm sure you'll find the issue. Okay, now before we move on to putting the second background on the screen, I just want to have a bit of a play around and experiment with the values we put into these functions. We are going to take a look at the tile attrib full, that macro that we nested inside the VDP draw image X function. I'm going to create another instance of the tile attrib full macro just so I can open the brackets and we can remind ourselves which each parameter does. So you can see here pal, prio, flip v, flip h and index. First of all, let's see what happens if we change from pal 0 to pal 1. Before we compile this, I need to comment out this tile attrib full because it's an incomplete line of code. Commenting out just means putting the 2 forward slashes in front of any line of code. It means the compiler would ignore it. It's just a comment. So we have to make comments in our code, as you can see in the example below as well. So let's comment that out and let's compile. And now the whole background has gone this red color, and that's because red is the default color of that palette when we haven't assigned any palette information to it. So remember previously when we did pal set palette, we dedicated the palette to pal 0, but if we change it to pal 1 now, it should begin to look a little bit more normal. However, we do seem to be missing one color. In my experience using SGDK, if you're going to create a background image, the far background, not the foreground, it's always best to assign it pal 0, otherwise it always seems to lose the first color of the palette. And after changing both of those back to pal 0, you can see that we're back to normal. For now we're going to skip over the priority one and we're going to look into flip v and flip h. So let's set flip v to true and let's see what happens. This has made every tile in the background flip vertically. I'll let you experiment with the flip horizontally yourself. You can set that to true if you want and see how it turns out, but you can probably guess what it's going to do. In this particular context, flipping the background tiles vertically or horizontally isn't really very useful, but it will be useful especially for sprites. For example, when Alucard or another sprite wants to turn around, we're going to flip that sprite horizontally so that he's not walking backwards. But for the backgrounds, normally the flip horizontally and vertically is done to save tiles rather than having the same tile but different shapes put into VRAM. Just one tile can be put in and then the system can flip it vertically and horizontally, but fortunately we don't have to do that manually when we create the background graphic, and I'll show you how to do that in a couple of lessons from now. You'll see that we just create the background graphics and we flip them themselves, and when we input it into the system, SGDK will recognize which tile has been flipped and flipped vertically or horizontally, and it would only put one of those tiles into the VRAM. Okay, I think it's about time that we put the second background onto the screen. Since we've already put one background onto the screen, this is going to be a pretty straightforward process as we're going to repeat the steps we did before. So first of all, we're going to actually load the graphic, the foreground graphic, onto our ROM in the resources.res folder. Again, image, then we're going to call this FG1, then we're going to put the file name in quotes and then best for the compression and then all. Since we already included the resources.res folder first time round, we don't need to do that again, but you'll probably notice although it recognizes BG1, it's not recognizing FG1 yet. So in order to get the C file to recognize it, we have to compile first, and as you can see now when I type FG, it automatically comes up FG1, it recognizes it, now it's been compiled. The one additional step we're going to have to do that we didn't do the first time round is to do this ind plus equals then bg1.tileset hyphen arrow num tile. Now just like when we did u16 ind equals tile user index, I'm not going to explain this in great detail. You can think of this as if we're going to put the tiles in the VRAM. So we've already put the tiles from the first image in the VRAM, and we don't want the tiles from the second image to copy over those tiles, otherwise it will cause problems. So we just do this so that we start copying the tiles for the second image into a different part of VRAM. If you want to experiment yourself, you can leave out that step and you'll see you'll get quite unusual results. But don't worry, you're not going to damage your Mega Drive console or anything, so go ahead. For the next step, we're going to set up the palette like we did last time, and this time we're going to set it to PAL 1 because they're using different palettes, they have different colors in the images. So again, like last time, we're going to take the palette information, what colors are going to be used, from the image we use for the background. So fg1.palette hyphen forward data, and then finally we're going to do the transfer via DMA. And finally we're going to use vdp underscore draw image x again like last time. So the most of the information will be the same, we're not going to mess about with it too much. The one thing that is going to change, a very important thing, is we're going to use bg underscore a, which is, you can think of it as the foreground layer of the background, so the foreground. And again, don't forget the ampersand, the and symbol when you put fg1, and then tile attrib full. We're not going to mess about with everything this time, we're just going to assign it to PAL 1, so make sure you put PAL 1 and not PAL 0. We're going to have some fun with that in a moment, we're going to mix them up, but for now just put PAL 1 and everything else as force, and then finally ind as well. And then after we're finished with tile attrib full, we're back into the main draw image function, and again the coordinates we're going to put them as 0 0. Again, we're going to play about with that in a moment, and then force for the little palette part of the function there, and finally true for DMA. And let's compile and run and let's see what we have. And now not only do we have the background, but we also have the foreground in too. So the foreground is the car and the lamppost and the fire extinguisher and the little bush at the beginning. And if you've managed to get that working, then give yourself another pat on the back, because now you've managed to display 2 layers at the same time. And if you haven't, just remember, check through your code, make sure there's no mistakes or typos, save and compile again, and hopefully it'll work this time. Now that we have 2 background layers on screen at the same time, we can have a little bit more fun with altering the parameters of the functions we've been using. So in this case, we're going to use the second parameter of the tile attrib full macro. We're going to change the priority. So normally the BGB will be at the very back and BJ in the front, but if we change the priority of BGB to true, let's see what happens. And now the lamppost, the car, and also the fire extinguisher and the bushes, they all appear behind BGB. So they appear behind the background, you can just about see them here. Now in this particular situation it wouldn't be very useful, but lots of situations it would be very useful. In Streets of Rage itself, for example, the sprites, which normally appear in front of both the background and the foreground, they're going to need to appear behind the foreground because they're behind the lamppost and the car, otherwise it looks very strange. So in that case, what we'll do is we'll put the foreground as true for priority and keep the background as false and the sprites as false priority, and that would make the foreground appear in front of the sprites, which is the effect that we need for a game like Streets of Rage where the foreground has to appear in front of the sprites. The parameter that I just changed from a 0 to a 10 here is the x coordinates of the background layer. So you can see on the screen right now in the emulator where the background has shifted right, but it hasn't shifted right by 10 pixels, it's shifted right by 10 tiles. So each tile is 8 pixels, so that's 80 pixels is shift to the right. And if I change that to 20, it's going to shift even more to the right, so now it's going to be 20 tiles to the right rather than 10 tiles. And while I'm here, I'm also going to change the y coordinates of the foreground layer. So I'm going to use a negative number here, which is going to shift the foreground layer up rather than down. And I'll explain why in a future video. And once we compile, you can see that the background's been shifted even further to the right now, 20 tiles, and the foreground layer's been shifted up, I think it was 5 or 6 tiles. Now, shifting the background layers around like this isn't very useful in this particular context, but in future we're going to show how to do parallax scrolling, and that's when it will be very useful. While I don't think this next step is strictly necessary, I'm going to add another index plus equals, and this time I'm going to do the FG1 instead of BG1, just in case you wanted to add another background or image later on and you didn't want to copy over what you did before, but it's probably not necessary because you've already compiled and this works fine, but just an extra step I like to do. And before we finish off for today, let's just have another little play around with the palettes. This time we're going to switch them round in the draw image X function, so we're going to make the foreground use the backgrounds palette and vice versa, and let's see what kind of effects we have. So if you get an effect like this when you're compiling, you know you've probably got the palettes mixed up, because it's not just changed to a red or a blue or some other color. It's actually they're using each other's palettes and the indexes are different. So I will explain a lot more about this when I come to do the lesson about how to create your own Mega Drive graphics and backgrounds and sprites and so on, because there's lots of interesting stuff in there. But the next lesson we're going to learn how to do parallax scrolling. I know that I personally was very excited the first time I did parallax scrolling, and it's great that we're going to cover it in just the second lesson of this basic tutorial series. From a coding standpoint, parallax scrolling is actually very easy to implement. It only takes a few lines of code, but we're going to use this to understand a lot more about how the Mega Drive stores and displays backgrounds, and as well as being just a very cool effect that I'm sure everyone will enjoy. I know from personal experience it is extra satisfying to see your work displayed on an actual Mega Drive or Genesis, so if you want to do that, simply go to the backgrounds folder, enter into the out folder within that, and then find the rom.bin file and simply copy that onto your flash card of choice and play it on your Mega Drive, Genesis, your CRTV, and I hope you'll be very proud of yourself. So we've got the first lesson over and done with, and I hope to see you next time for parallax scrolling. Until then,
farewell.